Hello and welcome to the video. Hope you're all keeping well. As I'm filming this, we're just reaching the end of the first lockdown due to COVID-19 here in the UK, and to keep myself busy and to do something good, I joined 3D Crowd UK. They were printing face shields for the NHS, the Prusa face shield design, and for the frontline staff as well. So my printer was busy for about 6 weeks, churning out parts for these face shields to be sent centrally to be assembled and sent off. During that time, PETG became a bit of a supply problem. Amazon were a bit hit and miss, and some of the prices on Amazon shot right up. So a kilo of PETG was costing up to £32, even more on some days, and was almost impossible to get within a few days of delivery as well. So I looked around, and Prusa were doing their PPE version of the PETG filament. So I ordered a couple of rolls of this. They were selling at a cost, which is good, and it printed really nicely, really well actually. So definitely worth using, and if you need any filament of any type, I definitely recommend getting some Prusa if you can afford it. The PETG from them prints quite hot compared with other PETGs, so I was printing at 245 degrees, which pushed my CR10 hot end to the limit. There was no way I could print any hotter than that, but it printed really nicely at that temperature. But it did raise a thought that I'd been having for some time, which is that I wanted to go direct drive and also to an all metal hot end to enable me to do different materials if I wanted to, but just also to print faster as well. So I had a look around, and E3D were doing the heat mirror setup, which looked like a really nice setup. Unfortunately, they didn't have any stock, and they couldn't sort of say on their website when they were going to get stock again, so that went out the window. I started looking on AliExpress, and I'd used a company on there called Mellow before, and they seemed pretty good. So I ended up ordering a NF-BMG Aero V6 HOTEND kit clone. Wow, they really could do with a shorter, snappier name for that, couldn't they? There are different options on there, and I went for option 4, which includes the stepper motor and the Volcano hot end, all as a complete kit. It cost me £56 with exchange rates, etc., and was delivered at about 2 weeks time, which was a fast delivery. So let's have a look, see what was in the box. So we get our extruder, and I went for the set 4, so I also get pancake stepper. Looks like some stepper driver cable. A few extra bags of bits and pieces, including a feeding tube and another different couple of Allen keys and some different length bolts. Bolts itself, got a couple of other bolts, a little cutter tool thing. Yet to discover what exactly that's for, presumably cutting the Bowden tube, but maybe electronics as well. And in the bag we've got Bowden tube. Let's figure this out. Volcano hot end, because that's the option I went with, and an all metal extruder. All metal extruder, and all metal hot end. We get the heater cartridge, 12 volt one, and a temperature sensor, that's good, and a fan as well, cooling fan, and a Bowden tube. Won't be needing that, but good to have it nevertheless. Okay, so let's have a closer look. You can see it's machined aluminium, CNC machined aluminium, and the fan flutes are directed away from the actual part. Hot end goes in here, and so none of the spilling air from that fan will go onto your part, which is nice. Let's just take it apart and let's have a look, see what the bits look actually like. So it drops down, 2 hob gears, and this just slides out. Lever arm there, there's a gear in there. So the housing, like I say, all a machined aluminium, but it's got a nice inset bearing there, which is good to see. it's not bearing against the aluminium. And then the plastic part, again another bearing on the other side. So the arm hub gear spins on this fixed shaft. Don't know whether there's a bearing in there or not, but it certainly spins freely enough. So yeah, first impression's pretty good. Nice finish, good quality machining, everything looks good, all lines up quite nicely. So mechanically, looks quite promising. Next step is to actually assemble it all. Take your hot end, heater cartridge, thermistor, etc. in there. Obviously your heat brake screws in there. Now you'll notice at the top of the heat brake there's a hole, and I presume that's to keep all the heat brakes standard, so that if you're using a Bowden system, etc., the Bowden tube will sit in there. I don't know. I don't understand why the void's there. Mellow, I contacted them and they suggest that that's why they supply the Bowden tube in with the kit. You put a piece of Bowden tube in there and cut it off flush. This is not flush, but you cut it off flush. If you don't do that and do what I did, which is just assemble it all with just the metal pieces, it will print fine. And I printed multiple parts fine, but the problem was when I did a filament change, it jammed. The filament got jammed and wouldn't feed in properly because the old filament was there as well, and yeah, it just wasn't happy. So yeah, remember that bit of Bowden tube in the top there will stop that happening. Assemble it all, back it off a little bit, so keep it a bit loose until you can get it on your system. Now I printed out a bracket from Thingiverse to get me going. Basically the brackets are quite similar, most of them, without the part calling parts, they're similar anyway. In that what they do is they're designed to hold the stepper motor on your carriage, and then this all clamps to the stepper motor. So if your stepper motor's there, it all clamps together, and that's what holds it all in place while you're doing the printing. So assemble it all, bolt it to your machine, get it to temperature, tweak it up so it's tight to stop the filament leaking out when it's molten. Once you've got it to temperature and tightened up, the next thing to think about is your E-steps. We've got a gear in here, so the gear means that everything's reversed. I'm using marlin, so in the bottom of config H there's a ball which will set the extrusion direction, so flip that, or you can apparently set the E-steps as being minus when you're setting up your E-steps. So with that flipped, again up to temperature, I marked 60 millimeters on my filament and just put a little line, extruded 60 millimeters at say 100 millimeters a second. I'm using a volcano, so that's fine. And then measure again to see what the difference is and calculate what your E-steps adjustment is. So my E-steps went from 100 to say 430, I think they are now, something along that, and tweak them until your 60 millimeters of filament extrudes 60 mil. The reason we do it with the nozzle on and etc. is because we need the pressure to be there. If you run it without the nozzle attached or run it cold, then you'll have no back pressure and you'll extrude more than what you would if it was all hot and the pressure was in the system. So once you've done that, got your bed level, you're ready to do your first print. I was ready for the first print, quite looking forward to it, all excited, no extruder, etc. And I printed a cube as you would do normally, and this is the cube and it's a complete mess. I was baffled, to be honest. I couldn't work out why going from a Bowden tube to direct extrusion would give me results like this. So we've got under extrusion, we've got over extrusion, same on the back. The cabin just fell off. It was under extruded around the edges so much. It was just, I was perplexed. Didn't know what was going on. Quite a few cubes later and a bit of Googling, I remembered what it is. It's linear advance. So in marlin there is a feature called linear advance, and it's a great feature for Bowden tubes. What it means is it extrudes extra at the beginning of the stroke and less at the end of the stroke, like this, to build up the pressure in the system. So it pre-pressurizes the system as the carriage starts to move, and then towards the end of your print it stops extruding, so that ooze actually continues the line and you get much better quality prints setting up your linear advance, once that's set up I should say. But obviously the numbers are going to be totally different between a Bowden system, which has got a lot of elasticity across the whole system, and a direct drive system, which has got a much shorter distance for elasticity to happen. So I recalibrated it and it went from like 1.3 down to 0.08 or something like that, a really small number anyway. And I printed out another cube and it come out, ta-da, as a square cube. Yay, fantastic. And then did a benchy come out decent enough benchy. Yeah, there's cooling part issues here and there, a bit of a droop and stuff. I didn't have a cooling part fan set up properly and ducting, etc. So that's why that was like that. But other than that, it's printed out as well as my old setup. My old setup was fine, but obviously this direct drive and I can extrude a lot faster. I can extrude about 3 times more material through that hot end than my previous one as well. It's worth mentioning. So tried that. This was PETG, the orange. This is PLA. Nice little print of a Stegi Saurus that a friend of mine modelled up. Another PLA print. This one is I think the water's got in this one. It's not. It used to be shiny. It's now all dull when I print with it. So presumably it's got damp. Tried flexibles as well. So this is it's not been cleaned up by the way, but this is Ninja Flex. So nice flexible, squashable sort of material. It ran out. It was only a sample. It ran out at the end, and this top plastic is Filaflex, which is much more flexible than Ninja Flex. But yeah, printed well. No issues, no problems with it other than the stringing, which is a standard sort of thing. You have to print slow with flexibles, by the way, even direct drive. So this is Filaflex again, but this one's been cleaned up a little bit around the legs and some of the stringiness has taken off. It's got a good amount of detail, hopefully you can see that, around the print, so very happy with that. So yeah, I've now got a direct drive printer and it's good. I'm happier with it. There's a few issues, like the fact that because it's mounted longitudinally along the carriageway, it's offset everything, which means I lose sort of 20-30 millimeters X and Y. So I'm going to drop it below the carriage, flip it around, and put the nozzle so that it's nearer where the original was. So I get my extra 20-30 mil back and I lose Z instead. But I've got 400 mil in Z using the CR10S. So I can afford to lose a bit of height without worrying about it. I don't ever print that high anyway. So would I recommend an extruder from a Chinese manufacturer? Well, if that manufacturer is Mellow, then yes, I would recommend it, definitely. If it's a quality manufacturer that you've used before, then don't be afraid to use them. If it's an unknown and you don't really know what you're buying, then don't complain if you're going to get sent, you know, something which is an unknown quality, I should say. But yeah, generally it's definitely worth trying them out, perhaps with some cheaper components first, and then checking that the quality is actually there before getting from them. A quick thing not related to manufacturing or printers and stuff, but a bit of an engineering thing. If while messing around with, say, a heat break or whatever, and you get it locked into place, finger tight but too tight to actually get undone, don't be tempted to use pliers on your threads. Another trick is to actually just thread a nut, a couple of nuts that you've got lying around of that same thread size. Just thread those onto the thread that you're trying to release, clamp the 2 nuts together to create a lock, then use a spanner on one of them to unlock the locked part of the thread out of the object you want, and then you can just simply unlock the 2 nuts and you haven't damaged any of the thread. So in case that comes in handy for you, I use that trick a lot and it's good. Right, so I think that's it. Brings us to the end of the video. If you liked it, if you're with us all the way through, then well done. You managed to put up with me for however long this video lasts. Please subscribe, like, all the usual stuff, and leave comments if you want to see any videos on any other things, or if you've got any other suggestions. I'm sure I made plenty of mistakes you can correct me on during it. I'll try and leave links to some of the stuff mentioned in a video in the comments as well. And that's it from me. So goodbye and keep safe. Thank you.